Today's lesson is on the quadratic formula, and the quadratic formula is the fourth method for solving quadratics. So far we've gone through factoring, square roots, completing the square, and today we're going over quadratic formula. Quadratic formula is the only method that works on every equation. So factoring is restricted, square roots is restricted, completing the square is restricted to certain equations. Quadratic formula works for everything. So what I mean by that is, if you think back to the first set of notes on solving quadratics by factoring, there was a few examples that we couldn't factor, so we wrote our answer as unfactorable or no solution by factoring. Now fast forward to quadratic formula, we could solve those equations using the quadratic formula. So given our standard form quadratic, which is in the form of ax squared plus bx plus c is equal to 0, we need to highlight a couple key terms: the a value, the b value, and the c value. And the quadratic formula is formulated by the equation x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Our a value, highlighted in green right here, occurs underneath the square root sign and in the denominator. Our b value, highlighted in purple, occurs outside of the square root in the numerator and underneath the square root value, or square root sign. And our value of c occurs once only under that square root symbol. So this equation here is the equation that you use, or you fill in to solve for a quadratic equation using the quadratic formula. When you're solving these examples, within solving, you're going to have to be able to simplify square roots and simplify fractions. So be very careful with those two concepts, as they do play a major part in your answer. Okay, number one, we need to get into standard form. So first thing is subtract 16 from both sides. X squared plus 6x minus 16 is equal to 0. From here, I know my a value is 1, my b value is 6, and my c value is 16. A value of 1, b of 6, c of negative 16. Oops, I forgot the negative sign there. Negative 16. Okay, now we're going to substitute these values into our formula of negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. Substituting our values in gives us negative 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 16 divided by 2 times 1. And I'm just going to highlight where my values show up. My a value is located in 2 places. My b value is located in 2 places. My c value is just once underneath the square root sign. So I always like to simplify, specifically simplifying underneath the square root sign first. Negative 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 1 times negative 16. That ends up being positive 64. All divided by 2 times 1, which is 2. I'm still simplifying what's underneath the square root sign. I have 36 plus 64. Negative 6 plus or minus the square root of 100 divided by 2. Right here, the square root of 100 is 10. Negative 6 plus or minus 10 divided by 2. All right, we have two answers. You need to be very careful of this plus or minus sign. So, given two answers, I'm gonna complete each one or simplify each one separately. So I'm going to start with our positive answer of 10. That means I'm going to simplify negative 6 plus 10 in the numerator divided by 2. Negative 6 plus 10 in the numerator would be 4 divided by 2, which is equal to 2. So that's one of our solutions. Next, I'm going to do minus 10. I should write that. That is telling me I have a numerator of negative 6 minus 10 divided by 2. This is negative 16 divided by 2, or negative 8. And just to clarify right here, this is one of the biggest mistakes I see. If you have a plus or minus sign, you have to simplify each one individually if you can. In this case you can, so make sure you find your two answers. I'm going to write my final answer as x equals negative 8, comma 2. Now if you want to check your work, you can substitute these two values back into the equation, the original equation, and solve to make sure it comes out to be true. So you could substitute them back into here and make sure it does work perfectly, so it is a true equation. Okay, number 2. Already in standard form, we have an a value of 1, a b value of 8, a c value of 16. When I substitute these values into the quadratic formula, negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 16 divided by 2 times 1. In the numerator, we have our square root to simplify. Negative 8 plus or minus the square root of 64 minus 64 divided by 2. (64 minus 64 simplifies to the square root of 0. The square root of 0 is 0. So we end up with a numerator of negative 8 plus or minus 0 divided by 2. Plus or minus 0 is not very helpful. We don't need to do anything with that. So our answer would be negative 8 divided by 2, or negative 4. For this expression, we have one solution, x equals negative 4. Number 3, convert this to standard form. Identify your A value as 2, your B value as -1, and your C value as -4. Always make sure you include those negative signs. X equals negative and then -1, so that will simplify to a positive, plus or minus the square root of -1 squared minus 4 times 2 times -4, all divided by 2 times 2. For the numerator, we have negative times -1, which we're going to simplify to +1. And we also have our square root that we need to simplify. The numerator is 1 plus or minus the square root of 1 squared, which -1 squared, which is 1. And then we have -4 times 2, which is -8 times -4, which simplifies to +32, divided by 4. One plus or minus the square root of 33 divided by 4. And you do have to check to make sure you can't simplify, or check to see if you can simplify, I should say, what's underneath the square root sign. In this case, you cannot simplify that, so we don't have to touch the square root. And you also need to see if you can divide out the denominator. It would have to divide into every term. So if the denominator, this number here, could divide into 1, and it could divide into, in this case it would have to have a coefficient, but divide into this term, then you could simplify. This does not work here, so here is your final answer. X equals 1 plus or minus the square root of 33 divided by 4. Okay, and our last example is number 4, 3x squared plus 5x plus 4 with an A value of 3, a B value of 5, and a C value of 4. Substitute these into our quadratic formula. We have -5 plus or minus the square root of 5 squared minus 4 times 3 times 4 divided by 2 times 3. -5 plus or minus the square root of 25 minus 4 times 3, which is -12, times 4, which is -48. All divided by 2 times 3, which is 6. -5 plus or minus the square root. 25 minus 48 is going to be -23 divided by 6. Notice that we have a negative sign underneath the square root. -5 plus or minus I, that takes care of our negative value, times the square root of 23 divided by 6. And again, check to see if you can simplify underneath the square root anymore. In this case, you cannot. Check to see if you can divide out the common denominator. You cannot. So this is your final answer. X equals -5 plus or minus I times the square root of 23 divided by 6. Okay, I'm gonna complete the on your own section. You can watch the video and see me do out these problems, or you can check your answer key on my website where I'll post this paper. There are 2 more pages on the discriminant. We're gonna save those till next class, or till Monday's class, I should say. So this is it for today after you complete the on your own section and do your practice.